Hi everyone, let's have a quick review of the important concepts that will come out on your test. Make sure that on top of this video, you would also do your practice test. Okay, so let's go ahead and get started. Let's look at this question here. Let R be the region in the first quadrant bounded by the graphs of y equal to x squared and y equal to 8 minus x squared. You are asked to set up an integral that represents the area of the region R. So to solve this, we first have to graph our equation. So it's very important that you graph the equations to have an idea of what your region R is. So let's start with that. So you just need a rough sketch of the graph. So you have y squared, y is equal to x squared. That is this curve here. That's a parabola. And another parabola, y equal to 8 minus x squared. So we know that we have a parabola that is concave downward. So when x is equal to 0, y is equal to 8. So it is this curve here. Now, take note that we're only interested in the region on the first quadrant. So you only need the first quadrant. So it is actually the region here. Now, next is to look at the limits of integration. So we know that we only need the first quadrant. So that means, or the region is only on the first quadrant. So that means we're looking at starting at x equals 0 and then up to here. And that happens to be the intersection of the two curves. So that means the first step, or the next step, is to solve for the intersection of the two curves. So the intersection of y equal to x squared and y equal to 8 minus x squared. So to get the intersection, just equate the two equations here. So we have x squared equal to 8 minus x squared, and then solve for x. So you can move or transpose this negative x squared to the other side of the equation. Then you have 2x squared equal to 8. Then you divide both sides of the equation by 2. You have x squared equal to 4. So that means that x is equal to plus or minus 2. Now, since we're interested again on the region on the first quadrant, so that means that x here is 2. So x is equal to 2. You can also calculate the y coordinate by just plugging in the value of x here. So if x is 2, 2 squared is equal to 4. So that is the point with coordinates 2 to 4. Now let's go ahead and set up the area of the region on the first quadrant. So this region here. Now to do that, we have two choices. We can either use a vertical strip or a horizontal strip. If you look at that, if you look at the choices here, looks like these are in terms of x. So that means that we are to use a vertical strip. So we're going to use a vertical strip to set up the area of the region. So area will just be the integral of, you just have to have a function at the top. I would say y at the top. That means the function y in terms of x at the top minus y at the bottom. So the function at the top minus the function at the bottom. And this is with respect to x. X starting at A to B. Okay, so what is the y function at the top? What is the function at the top? you locate that, or you identify that function, and that function is the equation or the parabola 8 minus x squared. That is y equal to 8 minus x squared. And then the function at the bottom, that means the top of the strip to the bottom of the strip. So the bottom of the strip touches the curve y equal to x squared. So this is the curve y equal to x squared. So the y at the top is 8 minus x squared, and the y at the bottom is x squared dx. And that runs from, now you look at the strip would run from here, from starting at this point, which is 0, so starting at x equals 0, up to this point here. So you just look at the x coordinate because your variable is in terms of x. So this is with respect to x. So x equal to 2. All right, so this is the integral that represents the area of the region on the first quadrant. Then that means if you look at the choices here, we would need to simplify this. So this is just equal to 0 to 2, 8 minus 2x squared dx. And that is choice C. Now let's proceed to question number 2. Find area of the region to the right of the curve x equal to y squared, and to the left of the line y equal to x minus 2. As the first step, you would always have to graph your region. Okay, so let's graph x equal to y squared. X equal to y squared is this parabola here. And then let's have the line y equal to x minus 2. So when graphing a line, you just need 2 points. So you would plug in a point for x, a value for x. So say for instance, when x is equal to 0, what is the value of y? Y is equal to negative 2. So this is 0. If x is 0, y is negative 2. And then next is to say, for instance, if x is equal to 2, y is 0. So if x is equal to 2, y is 0. So that would be the point. Then you can connect those 2 points. So that's your line. You just need the region, the intersection, which in this case would be the region here. So it says find area of the region to the right of the curve. So it's the right of this curve. That's to the right of the curve, and to the left of the line. To the left of the line. It is this region here. Then to find area, you always have 2 choices. You could use either a vertical strip or a horizontal strip. In this case, I would use a horizontal strip because I already have shown you in the first example how to use a vertical strip. So for the purpose of review or illustration, I'll use the horizontal strip in this case. Now, in your test, you can choose whichever you think is easier, in terms of what is given to you. Okay, so here, I would use a horizontal strip. Well, I can use a horizontal strip because I have here x that is in terms of y. Okay, yeah, you could also do that because then now when you write the area using a horizontal strip, the formula will be x at the right. So it's the function at the right minus the function. That means when I say function, it's a function of x in terms of y. Function of x in terms of y at the left. And this is now in terms of y. Now y runs from starting point A up to y b, the endpoint B. Now, so this is your strip. we know that this curve here is the line y equal to x minus 2. And this curve here is the curve x equal to y squared. So the area is x right. So the right curve, right of the horizontal strip. So if you have a strip here, it's this curve here. And that is actually the line, y equal to x minus 2. Now, we know that we have to write that in terms of y. So that means that we're going to solve the equation here in terms of y. So we are going to solve y equal to x minus 2. We will isolate x so that we could have x in terms of y. To do that, we can just move the negative 2 here to the other side of the equation. That gives us y plus 2 equal to x. So that means that the x at the right, which is this line here, is the expression y plus 2. So we have y plus 2 minus x at the left. The curve here at the left is the curve x equal to y squared. And that's already in terms of y. So we have y squared here, dy. Then you write the limits of integration. To do the limits of integration, the strip would run from here, from that point, up to this point. So up to this point, but we don't know what those points are. That means that we need to compute for the intersection points. The intersection points of the two curves. So to do that, we are just going to solve them simultaneously or by substitution. So we can replace the x here by y squared. So that means you have y and then replace x by y squared minus 2. And then you simplify this. So you have y squared, move the y to the other side of the equation so that the equation here, or this side of the equation, becomes 0. So minus y minus 2 equal to 0. Now we can factor. Y minus 2 times y plus 1 equal to 0. So y is equal to 2. The other one is y is equal to 1. Now, negative 1. So that means that at this point here, your y value is negative 1. And then at this point here, the y value is 2. Now, and that's what we're looking for, regardless of what x is. If you want to compute what x is, you just have to plug it in to one of the equations. So in here, you can plug it into this equation here. See if y is equal to negative 1, y squared is 1. And then if y is equal to 2, y squared is 4. Okay, but for the limits of integration, we know that we have to get the values for y. So y is starting at negative 1 up to y equal to 2. So then you go ahead and solve for the integral here. Okay, so let's integrate. We can also rearrange this. We can have negative y squared first as the first term. The integral of that will be negative y cubed over 3 plus, okay, let me write that down. Negative y cubed over 3 plus y squared over 2. That's the integral of the y here. And then plus the integral of 2, which is 2y. And then you evaluate that from negative 1 to 2. Negative 1 to 2. Okay, so plug this in. We have negative 2 cubed over 3 plus 2 squared over 2 plus 2y. Oh, 2 times 2, which is 4. I'll just write that as 4. And then minus, whatever the result here, minus negative 1/3, because negative 1 cube is negative 1, and there's a negative sign here. So let's have the negative of negative 1, 3, plus negative 1 squared is 1, so 1/2. And then 2 times negative 1 is negative 2. And then you simplify that. All right, so this is 4 squared over 2 is 4. 4 squared is 4 over 2 is 2. Plus 4 is 6. And this part here is also equal to, so 2 cubed is 8. So that's negative 8 over 3 plus 6. Minus, this is 1/3. And then we have here 1/2 minus 2 is negative 3/2. Okay. And then simplifying this, we have minus 8 over 3 minus 1/3. That makes it negative 9 over 3. Negative 9 over 3 is negative 3 plus 6 is 3. And then negative is positive. So positive 3/2. So this is equal to 6 plus 3, 9 over 2. So the answer is 9 over 2. Okay, so now let's proceed to question number 3. Let R be the region in the first quadrant bounded by the graphs of y equal to x squared and y equal to 8 minus x squared. This is actually the first problem that we have. But this time, we are asked to calculate the volume of the solid generated when this region is revolved about the x-axis. So again, in this problem, or in this type of problem, we would always need to first graph the region. So it's important that you know how to graph your basic functions. So if you recall, so the first example, this is how your region would look like. Okay, so we have a parabola here. This is a parabola concave down. And this is also a parabola concave upward with vertex at the origin. Okay. So now let's just erase some of the parts here. Okay. Now we just need that region. Okay, we would need this region, the region on that first quadrant, this region here. Now what we want to do for this region is to revolve this about the x-axis. So this is your x-axis. You're going to revolve that about the x-axis. Let's go ahead and delete some of the parts. Oops. Anyway, okay, cannot delete that. All right, and then okay. Now next is to, let me just fix that. All right, so that region, we are going to rotate it about this axis here, the x-axis. So in other words, if you rotate that, you would need a vertical strip, because we only learned how to find the volume either using a washer or a disk method. So in that case, our goal is to be able to create either a disk or a washer. But since so that means first let's create a vertical strip, and we want to rotate that about the x-axis. That means that this curve here will have a mirror image of that curve. We just need a rough sketch. So it would look like this. So this particular curve here would look like that. There we go. So this would be our solid. That's the solid when the region is revolved about the x-axis. Okay, so let's go ahead and set up. So sometimes you would, or there are questions, there will be question in the test where you would just be asked to set up. So if you're just asked to set up the integral, so you just do the first step. So you have the integral, the volume of that will be, this is using Washer method. So that means we're going to just get the area, the cross section here will be, the area here will be of that of a circle, of a disk. So that means you are to get the area of the outer circle, that means the bigger circle, minus the hole here. That portion there is a hole. So you want to subtract that. So you want the outer circle, so outer circle minus the inner circle. Okay, so and then you want to integrate that with respect to that area. Okay, so to do that, we know that this is a circle, so the area is just pi r squared. So you have a pi outside, and then we will have the radius of the outer circle. We denote that by capital R. And the radius, and then you square that, and the radius of the inner circle, and we denote that by R. Now, since we are using a vertical strip, this is a vertical strip. A vertical strip means that we are integrating with respect to x. So we are integrating this with respect to x. So that will be in terms of x. So your R will be a function in terms of x. The radius will be a function in terms of x. And that means it would follow, if it's a vertical strip, it would follow top minus bottom. So again, if it's vertical strip, that means top minus bottom. Function at the top minus function at the bottom. If it is horizontal, it is right minus left. Vertical is with respect to x. Horizontal is with respect to y. So here, pi, what is the outer radius? So you look at, let's change the color. Okay, so you look at this outer radius here. Again, we say top minus bottom. So look at that function. What is that function at the top? That is the function y equal to 8 minus x squared. Minus the bottom. Well, the bottom is just the x-axis. And what is that x-axis? That is the y equal to 0. So that means we have 8 minus x squared. We have 8 minus x squared minus 0. That's the radius. And then you square that. Minus the radius, the smaller radius, the inner radius. So for the inner radius, it will be this radius here. And what is that function? The function at the top of that. That is the function y equal to x squared. So this one will just be x squared. And then you have to square that as well. Dx. Then you simplify. So let's expand this. So expanding this binomial gives you a trinomial. So you square the first term, so you have 64 minus twice the product of the two terms. So negative 16x squared, and then square the last term, x to the fourth. And then here, that is just minus x to the fourth dx. Double check that your computations are correct. Again, 8 squared is 64, 2 times 8 is negative 16. Okay, and then square x squared. Good. Now, these two cancels, so you just have pi 64 minus 16x squared dx. Integrate that. You have pi, oops, and then we forgot the limits of integration. Okay, we were just computing without actually looking at the limits of integration. What's the limits of integration? We know that x runs from, we also already calculated for the intersection here. So coming from the first computation, look at the first step here, that is the point 24. 24. Okay, so hold on. This is the point 24. So if it's a separate problem, you need to compute for the intersection points. Okay, so since we are integrating this with respect to x, we are integrating it with respect to x. So our limits of integration will be from x equals a to x equals b. So look at x. So your strip would run from what value of x? Starting at x equals 0, because it's on the first quadrant, up to the value of x here, the value of x here, which is 2. So 0 to 2. So that's 0 to 2. 0 to 2. Okay, so let's integrate this. You have 64x minus 16x cubed over 3 evaluated from 0 to 2. Then you plug in. So you have pi, 64 times 2 is 128. And then you have 16 times 8. 2 cubed is 8 over 3. Minus 0, because all those with variables is 0 if it's x equals 0. And then you simplify. Right, and this would result to pi. Simplifying this, plugging this into your calculator, you will get 256 over 3. So the answer is 256 pi over 3. And that is choice A. All right, so for this next example, we are to use the same region, but at this time we're asked to calculate the volume of the solid generated when the region is revolved about the line y equals -1. So let's recall the graph of our region. This is how the graph of the region looked like. That point is 2, 4. And then we are now going to, instead of rotating this about the x-axis, like in the previous example, we're now going to rotate this at the line y equal to -1. So the line y equal to -1 is this line here. That is y equal to -1. Okay, so the solid, how does the solid would look like? Let's just make a mirror image. So it would somehow look like that. Okay. So this would be the, the solid. Now, to do this, we are going to, again, to create the washer, we will have to use a vertical strip. So this is the strip here. Now, if you rotate that strip, it would look like this, right? It would look like that. So then, to get the volume, we will just have to get the area of the outer circle minus the area of the inner circle. So we will have pi radius squared of the outer circle minus the radius of the inner circle. And since we are using a vertical strip, that means we're integrating with respect to x. Now, here, let's compute for the outer radius. The outer radius will be top minus bottom. So top minus bottom, that's the radius, the outer radius. So the one at the top, the function at the top, is the equation y equal to 8 minus x squared. And the function at the bottom is the equation y equal to -1. So that means we have 8 minus x squared minus -1 quantity squared. That's for the radius, the outer radius. Then for the inner radius will be from this point to this point. Okay, so that's the inner radius. It is this function here, and that function is the curve y equal to x squared. So you have x squared minus, function at the bottom is this line here, y equal to -1. That's the axis of revolution. And then you square that. Right. Now, for the limits of integration, you would look at the x values. So it's from the original strip. So the strip runs from this point here, so which is 0, up to this point here, which is 2. So from 0 to 2. Okay? Then you simplify it. So you have pi 0 to 2. Now we have negative, that makes it positive. So +1 plus 8 is 9. So you will have 9 minus x squared minus, and in this case here, negative is positive, x squared plus 1 squared dx. Okay, now let's expand this so we could simplify it. So we have pi equal to, expanding this, that is 81 minus 18x squared plus x to the 4th minus x squared, x to the 4th minus x to the 4th, double the product, so plus 2x squared plus 1 dx. And then you simplify it. So you have pi 0 to 2. Now the x to the 4th will cancel. So x to the 4th will cancel. And then now we have 18x squared minus 2x squared. So that gives you -20x squared. And then 81 minus 1 is 80. So plus 80 dx. Remember, I can just move that because addition is commutative. So I can, so the order doesn't matter. So now let's go ahead and integrate this. So to integrate this, we have pi integral of -20x squared is -20x cubed over 3 plus 80x. Then evaluate that from 0 to 2. Okay, so evaluating this from 0 to 2, we have -20. So let's have a pi here. -20 times 2 cubed over 3 plus 80 times 2. That's 160. And then minus 0. Okay, 0. If this is 0, this term will just be 0. Okay, and then you simplify that. So this is 8 squared. So that 2 cubed is 8 times 20 is 160. So that's negative 160 over 3 plus 160. And then combining those two will give you 320 over 3 pi. That's the answer. And what is that? Oh, that is choice D. So for number 5, we are to find the length of the curve defined by the given equation here, 9x squared equal to 4x cubed between the points 0, 0 and 2 square root of 3, 3. So you're given here the ordered pair. Now in this case, we are given an implicit function. So that means we're just going to use implicit differentiation to solve for the arc length. Now let's recall, what's the formula for the arc length? The formula for the arc length, L, is just equal to the definite integral of the square root of 1 plus the derivative of the function with respect to x squared. And it is from A to B. So that means we're going to get the derivative of our function. The derivative with respect to x or with respect to y. So this one is dx. If we're going to use the function here with respect to x. Or the other formula as well is that A to B, if we have the function in terms of y, so you just differentiate that in terms of y. And then you square it. Now this would be in terms of y. So y runs from A to B. So now since you are given an implicit function, then it's your choice. Whichever formula you think you feel more comfortable using, is that what you're going to use. But so for instance, if you pick on the second formula, for instance, that means you would have to solve this equation here in terms of y. So if you pick the first formula, then you would have to solve this equation here in terms of x. Okay. All right, so let me just pick the second one. So I will choose to solve this in terms of y. That means I will have to solve my function 9x squared equal to 4y cubed in terms of y. I'll divide both sides of the equation by 9. I'll have x squared equal to 4 over 9y cubed, and then x, therefore, you can compute x by taking the square root. So you will have the square root of 4 over 9y cubed, and that is equal to 2 over 3 y to the 3 halves. So it's the square root of y cubed, that is y to the 3 halves. Now we have an explicit function that is in terms of y. So therefore, next step is to get the derivative. So let's take the derivative dx dy of the given function here, so of that explicit function. So the derivative of that will be 2/3 times y, derivative is 3 halves, y to the 3 halves minus 1 is 1 half. And you simplify that, that is just equal to 1 half. Then we could plug it in to the formula here. So using that formula, we will have the integral of the square root of 1 plus the derivative. The derivative is y to the 1/2. Square it. Integrate it with respect to y. Y runs from, then you look at the given, your y. Look at the y values. It runs from 0 to 3. 0 to 3. So this is equal to 0 to 3. Now y to the 1/2 squared is just equal to y. So that is equal to the square root of 1 plus y dy. So that's what you are going to integrate now. Okay? So to integrate this, we will just have to use u substitution. So we will let u be equal to 1 plus y. Now your du is just equal to dy. Now remember, when you do the limits of, when you do u substitution, you would also change the limits of integration. So now if that limit is 0, if y is 0, if y is equal to 0, then you compute for u. U will become 1 plus, now you replace y here by 0, plus 0. So that's equal to 1. Now if y is equal to, look at that, the third limits of integration is equal to 3. Compute for the new u. The u value will be equal to 1 plus y, and y is equal to 3. So plus 3. So that's equal to 4. So therefore, this is just equal to the integral of square root of u du, new limits of integration from 1 to 4. So then you integrate that. So what's the integral? Integral of square root of u, think of square root of u as u to the 1/2. So the integral of u to the 1/2 is u to the 3/2 divided by 3/2. Then evaluate that from 1 to 4. So when you evaluate that from 1 to 4, this is equal to, get the reciprocal of that, 2/3. And then you have u is 4. So times 4 to the 3/2 minus 1 to the 3/2. So 4 to the 3/2, 4 is 2 squared. So the 2 will just cancel. So 2 cubed, so that's 8. And this is just, the second term is also 1 raised to any power is just 1. So you will have 2 over 3 times 8 minus 1, which is 7. So this is equal to 14 over 3. And that is choice letter A. Now let's proceed to the next number. Set up an integral when evaluated gives the area of the region bounded by y equal to sine inverse of x equals 0, and y is equal to pi over 2. Now, in any problem here, it is very important that you graph first. So that's why it's also very important that you remember the graph of your basic functions. So sine inverse is one of that. If you recall, the graph of sine function, sine of x, is this curve here. So this is from negative pi to pi. That's part of the graph of that sine function. Now, if you remember, when we talk about inverse function for sine, so this is in your pre-cal, we actually restricted the domain of that sine function so that we can talk about the inverse of sine. So the restriction is from pi over 2, from negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2. So if you restrict the domain of sine function on this interval here, then we can talk about the inverse of the function, because this curve now becomes 1 to 1. So that curve is 1 to 1. So when you look at sine inverse, you would actually think of the sine restricted at x from negative pi over 2 to pi over 2. So, and that's the graph of that sine x. Now, the sine inverse, to get the sine inverse, you remember, to get the graph of the sine inverse, you're just going to reflect the graph of the function. To get the graph of the inverse of a function, you just have to reflect it along the line y equals x. So that the graph of sine inverse will just be this curve, that's the reflection over that. So it is, let's just use the blue as a black. It is this curve over that curve. Okay, so that's the graph of that sine function. So the graph, when you talk about the graph of the sine function, it would look like this, that's sine inverse. And then you would have to change. So the y value, this is at pi over 2 to negative pi over 2. Because what's the relationship between the domain of the function and its inverse? The domain of the function is now the range of the inverse function. So for sine inverse of x, its range is the domain of that function. So the range will be from negative pi over 2 to pi over 2. Okay, now, and then what would be your x? The x value is from, x is from 0, from negative 1 to 1. Okay, x is from negative 1 to 1, negative 1 to 1 for the inverse function. Now, all right, so that's the graph. So here, let's go back to the problem. Set up an integral that when evaluated, the area gives the area of the region bounded by this. So let's graph that region. So how does the region look like? This region is, oops, that region, sine inverse. So sine inverse would be like this. You just need a rough sketch. Okay. And then x equals 0. So you know this is pi over 2. So that's y equals pi over 2. And then x equals 0. What is that x equals 0? The x equals 0 is actually your y-axis. So it is this line here. So that means that the region we're referring to is this region here. Okay. So we want to just set up the integral that gives the area. So if it's area area is just y at the top minus y at the bottom dx. X runs from A to B. That is when you are using a vertical strip. If you're using a horizontal strip, it will be x right minus x left. So function at the right minus function at the left. This is in terms of y. That's dy. And now y runs from A to B. Okay, so how would you know which one to use? Depending on what is in the choices. So look at the choices. Oh, they're all in terms of y. That means this suggests that you are going to use a horizontal strip. Okay, so let's use a horizontal strip. So that's the horizontal strip for the area. So now area is equal to, using a horizontal strip, x at the right. What is the function at the right? So it is this function here, which is the sine inverse. So if that is y equal to sine inverse of x, that means x is just equal to sine y. So x is just equal to sine y. So therefore, x at the right is just sine y. Minus x at the left. X at the left is this is the y-axis. So that is just 0. Minus 0. And then that's dy. Y runs from this point here, that's 0, up to y equals pi over 2. So the integral is just 0 to pi over 2 of sine y dy. Okay? And that is choice letter C. Alright, so for number 7, we still consider the same region R here, bounded by y equal to sine inverse of x, x equals 0, and y equal to pi over 2. And now we want to find or set up the integral that gives us the volume of the solid generated when that region is revolved about the line x equal to 1. So to solve this, we will have to draw first a region. We already have drawn that. So from that previous example, it is this region here, okay, that region. And we are going to rotate it about this line here, that is x equals 1. Remember, this is the point 1 pi over 2. Okay, so our region looks like this. This is x equals 1. That's the line y equal to pi over 2. Now, we will revolve this about the line x equals 1. So about this line here. So we are going to revolve it about that line. Now, the graph or the curve will then, the solid will then look like this. Okay, so it will be like that. Solid would look like that. All right, now you look at the choices. So for the choices here, looks like these are all, we cannot use this because this one involves the cylindrical shell method, which we did not actually cover in this class here. Okay, so now we know that probably there's not in the choice here because the only time that it will be in terms of x is when we use that vertical strip. If we use that vertical strip and we rotate that strip, that would result to a cylindrical shell, which we did not discuss in this class. So I would say we will just abort the choices there. Okay, and we will just set up the volume here, how we would solve this when it's revolved about the line x equals 1. So in this case, we would have to use a horizontal. We would have to use the horizontal strip to solve that. Okay, that is what is covered in the class. So if we're going to use a horizontal strip, that means we're going to use the washer method. Okay, we're going to use that washer method. Now, so use washer method. Okay, so now to get the washer method, the volume will just be pi radius, outer radius squared minus inner radius squared, and then this will be dy because you have a horizontal strip. Okay, now when you have horizontal strip, you follow right minus left, right minus left. So let's take a look at the outer circle. So the center would always be the axis of rotation. The center would always be the axis of revolution. So the axis of revolution is 1. So starting at 1 up to the end. Okay. So now it would always be right minus left. Okay, right minus left. So that means when you set up the radius, the outer radius, it is the left function, which is 1, minus the right. What is at the right? Right is this x equals 0. So minus 0. So you just square that. Minus the other one. The other one will be here, the inner one. So it would still be right. So the right is the line x equals 1. So 1 minus this curve here, that curve, this curve, which is, that curve is the function y equal to sine inverse of x. But since we want x, so we have x equal to sine of y. So x at the left is sine of y. So sine y, and then you square that. dy. Now your strip would run from starting here, 0, up to, you end here, y at the top, which is pi over 2. Okay, so this is the volume. So again, in this case, we cannot solve this or using the principles that we learned in the class, which is either washer or disk method. We won't be able to solve this in terms of x, but we would be able to solve the volume, but it would be with respect to y and using the washer method. If it's going to be in terms of x, like in the choices here, that will use cylindrical shells, which we did not discuss in this class. All right, so that's how you would set up the volume of this of the solid here. So and now for the final problem, we want to find the volume of the solid by revolving the region bounded by the y-axis, the line x plus 1, and the line x equal to negative x plus 3 about the x-axis. So first, you have to graph this to be able to imagine what the region is. I don't really know how you would solve this without graphing. Okay, so now you will have to graph the line. Remember, when you graph a line, when you plot the line, you just need 2 points. So find those 2 points. So make that when x equals 0, y is 1. When x is 0, y is 1. Now when y is 0, x equals negative 1. Okay, so it is this line here. Then this line, for this line, we have when x is 0, y is positive 3. So 2, 3. Y is positive 3. Now, when y is 0, if this is 0, x is equal to 3. So 1, 1, 2, 3. So it will be this curve here. So if we are to find the region bounded by the y-axis, and then this is the y-axis and the two lines here, so we're actually referring to the region here. We're referring to that region. Okay. And then we want to find the volume of the solid by revolving the region bounded by that about the x-axis. So it is going to be rotated here. Okay. That's going to be rotated there. Now, to solve that, you can redraw it, and then you don't need to worry about, you can make it a little bit larger. Okay, so that's the idea. Then you can just assign here the intersection. There should be that intersection point. And you can solve that by solving simultaneously the two equations. So we have y equal to x plus 1. Then you have y equal to negative x plus 3. Adding this 2 will give you 2y plus 4. So y is equal to 2. Y is equal to 2. And then you just plug in to any of the equation here to solve for x. So if y is 2, so 2 equal to x plus 1, that means x is equal to 1. So therefore, this point here is 1, 2. So that's also 1, 2. Okay. And what was this point here? That is 0, 3, and this is 0, 1. All right. Then, so now that we have that region, we want to revolve that about the x-axis. So this is the axis of revolution. So then we can create the mirror image of that region in here, like at the bottom. So we have an idea of how the solid looks like. So that's how the solid looks like. All right. Okay, so now to find that volume, we will have to use a vertical strip. So how would you know which strip to use? You would always think that the strip should always be somehow perpendicular to the axis of revolution. So if you have a horizontal strip here, like for instance a horizontal strip, that's not perpendicular to this line, it's parallel to that line. So therefore that means you don't use that. So you would have to use a different strip, which is a vertical strip. So we use that vertical strip that's perpendicular to the axis of revolution. Okay, now, so we have that. Okay, y-axis. So let's set up the volume. So volume is equal to since this is this is a vertical strip, so that means this is with respect to x. So top minus bottom. So when you say top, you look at the outer radius. So it's outer radius squared minus inner radius squared. We expect this to be with respect to x. So here, from that point to this point. That's the outer radius. So top minus bottom. What is this function here at the top? The function at the top, that is the line y equal to negative x plus 3. So you have negative x plus 3 minus the bottom, which is just 0. And then you square it. Minus the inner radius. So the inner radius is this radius here. So what's the function at the top? The function is at the top is this line here. And that line is actually the line y equal to x plus 1. So you will have x plus 1, that's the top function, minus the bottom function is the x-axis. And then you square that, dx. Now you would write the limits of integration. Let's look at the limits of integration. You look at the x-axis. So for the x-axis, starting at this, or the x values, the x coordinate is from 0 to 1. So it is from 0 to 1. So starting from here to here. So that's from 0 to 1. And then you simplify it. 0 to 1. Now, simplify this by expanding the binomial. You have x squared plus 6x, not 6 minus, because of the negative sign here. So minus, so double the product, and then square the last term, which is 9. Minus, this is x squared plus 2x plus 1 dx. Then you simplify it. 0 to 1. The x squared cancels. So that's 0. Negative 6x minus 2x is negative 8x. And then 9 minus 1 is 8 dx. Then integrate this. You have negative 8x squared over 2 plus 8x. Then evaluate that from 0 to 1. Now we can simplify this. That's equal to negative 4. So you will have negative 4 plus 4 minus 0. Oh, not 4. Plus 8. Plus 8. So the answer is 4. And I forgot to put the pi. You will always have to put pi here. That's the formula. So that should be, there should be a pi here. Pi. Okay. So the answer is 4 pi. And that is choice A.